Ever wondered what polar coordinates are and why they are so important? Well, imagine a world where we can pinpoint an exact location or movement, not solely based on horizontal and vertical directions, but also on angles and distances. Welcome to the fascinating realm of polar coordinates. In the two-dimensional coordinate system we're all familiar with, we use Cartesian coordinates, where each point on a plane is determined by two distances from the vertical and horizontal axes. Polar coordinates, however, offer a different perspective. Each point is determined by its distance from a reference point and its angle from a reference direction. The reference point in polar coordinates is known as the pole, and the ray from the pole in the reference direction is the polar axis. Now, to specify a point in polar coordinates, we use two values, r and theta. R, the radial distance, is essentially the distance from the point to the pole. Theta, the polar angle, is the angle between the polar axis and the line connecting the pole to the point. Polar angles can be measured in degrees or radians. In mathematics, it's conventional to measure polar angles counterclockwise from the positive x-axis. But in other fields, like navigation, the measurement is clockwise from the positive x-axis. Let's illustrate this with an example. The point 2, 4 in Cartesian coordinates translates to polar coordinates as such. R equals the square root of 2 squared plus 4 squared, which simplifies to 2 times the square root of 5. Theta equals the inverse tangent of 4 divided by 2, or arctan of 2, which is approximately 63.4 degrees. To convert from polar to Cartesian coordinates, use these formulas. X equals r times the cosine of theta, and y equals r times the sine of theta. To reverse the process, to get from Cartesian to polar, r equals the square root of x squared plus y squared, and theta equals the inverse tangent of y divided by x. Polar coordinates are incredibly useful across various fields, from mathematics and physics to engineering and navigation. They can represent the motion of a planet around the sun, calculate the area enclosed by a polar curve, solve differential equations involving polar functions, design antennas, and even navigate ships and aircraft. Polar coordinates also give us fascinating shapes through their equations. For example, the equation for a circle is r equals a, where a is the radius. The cardioid's equation is r equals a times 1 minus the cosine of theta. The spiral of Archimedes is given by r equals a times theta, and the lemniscate of Bernoulli has the equation r squared equals a squared times the cosine of 2 theta. In summary, polar coordinates provide a unique way to represent points and shapes on a plane, using a combination of distance and angle. This system offers a powerful tool for solving problems in a variety of fields, enabling a deeper understanding of the world around us. So the next time you look at a map or a graph, remember, there's more than one way to pinpoint a location or represent a movement.